According to the National Electrical Code, all concrete encased electrodes that are installed must be bonded to the grounding electrode conductor. This means that if you have multiple concrete encased electrodes, each one needs to be connected to the grounding electrode system. The purpose of a concrete encased electrode, often referred to as a UFA ground, is to provide a supplementary grounding electrode that enhances the overall effectiveness of the grounding system. A concrete encased electrode is typically constructed by encasing at least 20 feet of bare copper conductor, size no smaller than number 4 American wire gauge, within a concrete foundation or footing. The concrete must be in direct contact with the earth. This creates a large surface area connection to the earth, providing a low impedance path for fault current. The National Electrical Code Section 250.52 A3 outlines the requirements for concrete encased electrodes. The code mandates the minimum length of the conductor, the size of the conductor, and the requirement for direct contact with the earth. Ensuring that all concrete encased electrodes are bonded to the grounding electrode conductor enhances the reliability and safety of the electrical system by providing multiple paths for fault current to return to the source. This reduces the risk of electrical shock and minimizes damage to equipment during fault conditions. The grounding electrode conductor connects the grounding electrode system to the equipment grounding system and the neutral conductor at the service equipment. This connection ensures that all non-current carrying metal parts of the electrical system are the same electrical potential, preventing voltage differences that could create a shock hazard. When installing concrete encased electrodes, firstly, ensure that the concrete is in direct contact with the earth. Secondly, use a bare copper conductor that is at least 20 feet long and no smaller than number 4 American wire gauge. Thirdly, bond each concrete encased electrode to the grounding electrode conductor using approved methods and connectors. Fourthly, protect the connection from corrosion, especially in harsh environments. Finally, inspect the installation to ensure compliance with the National Electrical Code requirements and local regulations. Common mistakes to avoid include using an undersized conductor, failing to ensure direct contact between the concrete and the earth, and neglecting to properly bond all concrete encased electrodes to the grounding electrode conductor. These mistakes can compromise the effectiveness of the grounding system and increase the risk of electrical hazards. Regularly inspect and maintain the grounding system to ensure its continued effectiveness. Check for corrosion, loose connections, and damage to the conductors and connectors. Repair or replace any damaged components promptly to maintain the integrity of the grounding system. In summary, the National Electrical Code requires that all concrete encased electrodes that are installed must be bonded to the grounding electrode conductor. This ensures a reliable and effective grounding system, enhancing the safety and performance of the electrical installation. Always refer to the latest edition of the National Electrical Code and consult with a qualified electrician to ensure compliance with all applicable requirements.